What's happening, dogs? Mr. Allen here with some exponential fun, right? We're going to be solving some of these exponential equations here, and we do not have like bases in these things, but perhaps we can get some like bases. So we want to solve each one of these for x. That is the goal. We got 3 raised to the x plus 5, okay? And I got 1/9 raised to the 2x plus 1. Well, 1/9 could be rewritten, right, as a base of 3. Here's what I mean. So we got 3 to the x plus 5. I'm going to leave that. But 1/9 could be 3 to the negative second. Let's think about our exponents. 3 to the second is 9. Negative exponents cause the reciprocal. I get 1/9. All right, so we're moving, man. We're moving here. Now my next thing with exponent properties. Power to a power, multiply the exponents. So again, my left side is going to stay as is. But my right side here is going to be negative 2 times 2x is negative 4x. Negative 2 times 1 is negative 2. And now we have like bases. So I can set my exponents equal to each other. That's the one-to-one property of exponents if I have like bases. Set the exponents equal. I'm going to add 4x over, so plus 4x plus 4x. And I get 5x. We'll subtract 5. We get equals negative 7. And we get this absolutely awful but wonderful, wonderful fraction here, negative 7 over 5. Final answer, bingo, bango. We can have negative exponents. We can have negative answers for x. We can have negative exponents as a final thing. It's when you're solving with logs, you're not allowed to have negative arguments, okay? So we don't really have to check for extraneous solutions here because there are no domain restrictions when it comes to exponential functions. I can plug anything I want in for x. So since I can do so, we're good to go, all right? So negative 7 over 5, or you can convert it to a decimal. I'll leave it as a fraction. All right, next one. This one looks a little more challenging. Because what the heck is going on here? Well, 1/8, we could rewrite that as a base of 2, kind of like what we just did here. 16 can be written as a base of 2, and I've already got 2, oh my god, raised to the x squared. Let's start with this, right? Let's start with writing with a base of 2. So over here on the left-hand side, I'm going to have 2. 2 to the third is 8, so 2 to the negative third would be 1/8 with the x. I got 2 still to the x squared, whatever the heck that is. And then 16 would be 2 to the 4th. So over here on the left, I'm going to have 2 to the negative 3x equals, like bases though actually, right? I got 2 raised to the x squared and 2 raised to the 4th. If I have like bases, as ugly as this is, I can subtract my exponents. Let's do that. So I'm going to have 2 to the x squared minus 4. Oh, one-to-one property. We're set, man. We got 2 to a power equals 2 to a power. Exponents must be equal. Negative 3x equals x squared minus 4. I have a quadratic, which means I get to factor. Yes. Just when you thought it was gone, because we're dealing with exponentials, factoring comes back. It never goes away. Never, ever, 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 ever going away. Okay? Factoring is here to stay. You got to learn it. Now, I would set it equal to 0 over here so that my x squared is positive, okay? It is impossible to factor with a negative lead coefficient, right, in front of your x squared. Do not subtract that x squared over. Everybody tries to do that, and it never goes well. I don't know why, but it seems like it's impossible, so I'm not even going to try it, okay? So we got 0 equals x squared plus 3x minus 4. Always have your lead coefficient positive, okay? Kids try to do it. Doesn't work out well. Just easier this way. So now I've got x and x. Well, what multiplies to negative 4 and adds to 3? That's going to be positive 4, negative 1. So I can set x plus 4 equal to 0. I'll get x equals negative 4. And I'll get x minus 1 equals 0. So I'll get x equals positive 1. Boom, boom. Wonderful. You can even plug them back in and see if they work. I'm not going to do that right now. Ain't nobody got time for that. Well, you could. Maybe you have time for it on a test and you're like, I'm going to double check myself before I wreck myself. But that's it. Again, no domain restriction there for exponentials because you can plug whatever you want in. Your graph of an exponential function looks something like this, right? So all my x values exist. It's my range, my y values that do not exist there below the x-axis and on the x-axis. All right? Cool, awesome, fantastic, wonderful. That was exponentially fun. See you later.